Hello guys, Ashutosh here. How are you all doing? Today in this video, we are going to talk about the stress-strain relationship, which is very important topic in biomechanics. So before starting the video, if you are new on this channel, please do subscribe and hit the notification bell to get the latest updates first. अगर आप एंगल ऑफ पुल समझना चाहते हैं तो आई बटन पे क्लिक कर सकते हैं और मेरी वीडियो उधर जाके देख सकते हैं। वीडियो को लास्ट तक ज़रूर देखिएगा। सो लेट्स बिगिन। स्ट्रेस स्ट्रेन रिलेशनशिप जो है वो बहुत इंपॉर्टेंट एक टॉपिक है जो कि ग्राफ के मदद से हम रिप्रेजेंट करते हैं। सो हियर वी हैव स्ट्रेस एंड स्ट्रेन। सो स्ट्रेस स्ट्रेन रिलेशनशिप which is a very important curve or very important topic in biomechanics. So let's start. Here the curve represents each of the points on the curve represents something. So we will see point wise what does it mean and what does it signifies. So we have marked various points here A, B, C, D, E and F. So various points are there and they have altogether a individual significance. So we will see what does this points mean and what does this stress strain relationship say to us. So first is the point O to A. So what does this line signifies? This is the Hooke's law. Basically here from O to A the Hooke's law is obeyed. So we will see what does the O to A means. So here it is written that from O to A Hooke's law is obeyed, that is to say straight line is obtained which shows stress directly proportional to strain. So we have written in short form that stress directly proportional to strain. So here from O to A the stress is directly proportional to strain, so we can say the Hooke's law is obeyed. So from O to A Hooke's law is obeyed, so we have this straight line signifying the stress direct proportionality with the strain. So here we have marked the point A as Hooke's law limit, means till this point the Hooke's law is being obeyed. Next is the point A to B. What does this signify? So from A to B it is the elastic region where the Hooke's law is not obeyed, that is why no straight line is obtained. Here we can see that A to B is not a straight line, it is somewhat curved. So we can say that here the Hooke's law is not obeyed at all. So we can say from A to B Hooke's law is not obeyed. Hooke's law is only obeyed from O till A. From A to B the Hooke's law is not obeyed. At the point B we can see the point is known as elastic limit, means till here the elasticity of the object or material or anything exists, and after this the elasticity keeps on decreasing and decreasing. Next point is B to C. B to C is from B to C plastic deformation zone. Hooke's law fails and extension in the wire is partly elastic and partly plastic in behavior. So here we have taken the example of, we can say, wire. So in this case from B to C it is the zone of partly plastic and partly elastic, because the elasticity, as I have said, that keeps on decreasing. So in this region from B to C the elasticity keeps on decreasing along with the increasing plasticity. So elasticity decreases along with the increase in plasticity. So that is why this B to C zone is called plastic deformation zone. So here we got the next point, that is C point, which is the yield point. Now from C to D we have increase in the strain without any increase in the stress. So we can see that here from C to D the stress is same, the stress is not changing, but you can see the strain is increasing, because on this axis the strain keeps on increasing but the stress do not increase here from here to here. So from C to D stress do not increase but the strain does. So we can say that from C to D, increase in the strain without any increase in the stress, material begins to flow and it remains perfectly plastic up to D. So we can say the material remains partly plastic till D, and after that it starts becoming more plastic and the elasticity keeps on decreasing and decreasing. So beyond D, we say that the thinning of the material starts. So basically beyond D, thinning of the material starts, known as necking, till E, which is the point of ultimate stress or breaking stress. So we can see here that from D to E, the stress keeps on increasing, and here we get a point known as breaking stress or ultimate stress. Till here, the thinning of the material keeps on decreasing. The material starts to thin, like for say rubber band, if we stretch more, it keeps on decreasing in diameter. So here is the same. We say the phenomenon of necking starts from D to E. We usually see thinning or necking of the material, and we reach a point which is known as breaking stress or ultimate stress. After that, from E to F, we have decreasing trend of the graph. What does it signify? After that, the wire starts breaking even more and finally breaks at the F point, known as the breaking point or fracture point. So as I have told that the wire starts the phenomenon of necking from D to E, and the stress keeps on increasing and increasing up to a limit, and after that at the point F, the material breaks, because the material has reached up to a limit, and this point where it reaches the limit and breaks down is known as breaking point or fracture point. So either we say it as breaking point or fracture point. So at F, we obtain a breaking point or fracture point where the object breaks or gets fractured. In this graph, we can see that area under this represents the elastic region, because we have told that till here the Hooke's law is obeyed, and after that Hooke's law is not obeyed, but still the elasticity is maintained till B point, which is the elastic limit. That's why we call this area under graph here is the elastic region. So this is basically the elastic region, and if we move to this region, this is known as the plastic region. So from here to here this full is known as the plastic region, because till here the elastic limit is there, means the elasticity is still there, but after this elasticity keeps on decreasing and the plasticity keeps on increasing. That is why we call this area as plastic region. So this is the elastic region and this is the plastic region. So this is how we obtain the stress strain curve like this, which is usually the stress strain relationship, which is signifying how the material is being acted upon by the stress, and how does the material is often work under stress and strain, and how the proportionality works here. I hope you are cleared with all your doubts regarding stress strain curve. If it is so, then please give it a big thumbs up and share as much as you can. If you haven't subscribed my channel, then you're missing out. And also hit that notification button to get the latest updates first. You can also follow me on various social media handles, links down in the description box. Okay then guys, मिलते हैं अगले किसी ऐसे ही नई इंटरेस्टिंग वीडियो के साथ और करते हैं बहुत सारी बातें. So until next time, आशुतोष here, signing off.